The trays that have a spacer, some of them have complete spacer following all of the tray outline from the inside, or partial spacer. Remember that at the clinical step, we're going to remove the spacer once we take the impression. So the impression is not taken with the wax inside. The impression is taken after we have done a step called border molding. This is the these are the clinical steps. So border molding, take out the spacer, and then take the zinc oxide alginate impression. So the cases that don't have any spacer, we will put the zinc oxide eugenol, and this zinc oxide eugenol will be pressed between the tray and the tissue beneath firmly. That means all of the tissue are displaced. But in the cases where we have a spacer, that means once we remove this spacer away, the impression material
has some sufficient space inside the areas where the wax was there. This thickness of the material allows it to be static, mucostatic, meaning that it does not press the tissue away from its resting position. So you record the tissue at the resting position. What about partial spacer? Partial spacer means that I'm placing the spacer in areas we call relief areas that we should not exert pressure on for many reasons. While the areas without any spacer, we have the tray closely fit to the tissue. So in these areas, the impression material will be squeezed between the impression surface of the soft tissue and the tray. So this area will be firmly compressed. These areas are firmly compressed, and these are called support areas. In the areas where there is a spacer, the impression material will have space for it to set. It will not be squeezed firmly between the tray and the tissue, so we will have a mucostatic state of the impression material. So in these areas, we do not have pressure on the tissue. On this cast, you see that the denture-bearing area is divided into two parts. The areas that will be compressed, and those are called primary support areas, and the areas that will be relieved, and these are called relief areas. Why do we need not to compress these areas and leave the impression material in a mucostatic stage, and not press it as we can do here and here? We need to look closely at the histological section of these areas. To understand the issue about compressibility, we need to look at the histological sections of the tissue. We know that underneath what we see in the patient's mouth, there is bone. We have a mucosa, submucosa, and mucosa layers. By nature, these layers are compressible. They have some flexibility. We can compress them and they change in location. So when they're resting, they have a position, and once under pressure, they maintain a different position. This is called compressibility of the tissue. If I bring a tray and place it over this mucosa and tissue and press without any spacer, that means the tissue will be recorded at this stage, which is the compressed stage. So I'm trying the tray at the beginning like this, then I place my impression material in between, and then take the tray and squeeze. This means that the impression material is squeezed between the tray and the mucosa and the layers beneath. That means everything is compressed and recorded as such. This is called compressed status. The areas that tolerate this way of compression and function with the denture end in this compressed status are what we call primary support areas. And these are the hard pellet, the tuberosity, and the slopes of the ridges. These could withstand such pressure. denture is inside the patient's mouth, these areas can tolerate the denture to be compressed, and they have good quality of bone beneath them. They have compact bone. That compact bone can tolerate that pressure. So if we take the bones of mucosa, and impression material and the tray pressed all together, this is called mucocompressive impression material, and the status of the tray is closely fit to the mucosa before adding in the impression material. And the tissue status underneath is compressed. So that's why we call it tissue compression method. This can be once more done with a tray that has no spacer in that area. The impression material is squeezed between the tray and the mucosa. The mucosa has some compressibility, and the bone itself could withstand such pressure. What happens in the case of the presence of the spacer? So this is a tray with a wax spacer in, and the mucosa, submucosal bone. We take our Borla molding, see that the tissue is not compressed, and once we're ready to put in our impression, we remove the spacer and the tray, put impression material in here, in the tray, and come and begin squeezing. With the spacer preserving the space for impression material, we could not squeeze a lot, because we also have stoppers maintaining the space. So no matter how much I squeeze, the impression material stays not in a totally compressed status. This is called mucostatic. Notice that the mucosa, submucosa are not in a compressed status as they were in tissue compressive technique. So this relief that we made with wax maintained a space for the impression material to be equal in space, not exert any pressure on the mucosa while I'm pressing on the rest of the impression. The areas that follow this are in the lower, or the relief areas, crest of the ridge and the mental foramen area, while in the upper they are the crest of the ridge, the interstitial area, Rogge area, and mid-palatine raphe area. The posterior area of the hard palate, which is considered as primary support area, can tolerate pressure for a different reason as well. Other than having good quality of bone and having tissue that is compressible and not very thin, it also has a layer of glandular tissue. This layer of glandular tissue is compressible, and we can compress it in the same manner we compress the rest of the tissue, but also we could even press it a bit more by adding something called a post-dam area. So even in this area we exert further pressure, and this is the posterior area of the palate on both sides here. Now we're going to review reasons why we need to relieve these areas using wax. The first reason is present in the following areas: around the tuberosities if they are bulbous, around the undercut areas, and in the mid-palatine raphe area. This reason is that underneath the mucosa, the submucosal layer was not thick as the other areas we have shown earlier. It is a thin layer, and underneath it is hard bone. So if we compress this mucosa like this, and it's trapped between the denture material later and the bone, this mucosa can be easily traumatized because it's thin and the layer of the submucosa beneath it is thin. So these areas, if under pressure, can be easily traumatized under the denture. The second reason why we need to relieve is the presence of bundles of nerves and blood vessels beneath the mucosa. So the mucosa is normal, the submucosa is normal, but there is a bundle of nerves that is going in that area, out from that area to supply the soft tissue in the mouth. These areas are in the upper, the incisor papilla area, and in the lower, the mental foramen, where the mental foramen bundle of the nerves and blood vessels come out. With the result these bundles come closer to the crest of the ridge. So what happens if we press? So once more, the mucosa are normal, but this bundle of tissue, bundle of vessels that's going out, could be compressed. So suppose that the denture is going to function and the patient is biting out that and force is exerted on the denture. That will cause this compression of the tissue over the bundle is compressed. What will happen is, with minor pressure, we will have a tingling sensation. The patient feels uncomfortable with the denture. But if further pressure is exerted, pain signals will be like shocking electricity, so the patient will not tolerate that pain. So these areas are relieved because the presence of bundles of blood vessels and nerves in that area. The third reason sometimes when we need to relieve an area is the presence of bone specules. These sharp bone specules can be present in the form of the mid-palatine raphe. Underneath it we have the bone where the suture had closed and that bone is projecting. And in the lower, that can be in the areas where we have knife-edge ridge. So this sharp bone specule is present and the mucosa is pressed. The mucosa overlying it will be traumatized by this bony specule. So also those are areas that need to be relieved. And another reason why we need to relieve are the ruby areas here. This ruby area is a bit rough. This irregularity in the mucosal layer or in the surface of the tissue, if under pressure, it will be squeezed underneath the denture and will not tolerate the denture pressure, so we need to relieve the ruby area. The final reasons where sometimes we need to relieve is the quality of the bone. Compact bone has more mineralized tissue in it, so under pressure, with time, it can tolerate all pressures over it. But if we come to spongy bone, or cancellous bone, this area is empty, while the calcified material is less. That means, if I exert the same pressure on both bones, this bone will resorb slowly, while this bone resorbs fast. And I will lose the basal seat area, and I'll lose the ridge height underneath the denture. And this is traumatic to the patient on the long term. So on the long term, it will have a lot of resorption. So we avoid areas that have spongy bone exposed. Those areas are the areas where we have teeth in the dentate patient. So after extraction of the teeth, the alveolar process areas, once they resorb and fill in with fibrous tissue and then bone, they don't go back to compact bone. They stay spongy and cancellous. So the bone quality on the crest of the ridges is of the type spongy or cancellous bone. While on the slopes, it's the original compact bone that we have. So we try to relieve the crests of the ridges, even if they are not knife-edge shaped, because they, on the long term, tolerate the pressure less. That means they will resorb more. So if I exert even pressure all around, these areas will resorb faster because the quality of the bone relief. So in these areas we relieve, while on all of the slopes of the ridges, we have compact bone, good compact bone, and we can pressurize as much as possible. So once I understood the different reasons why we need to relieve these areas in orange, these are all the relief areas in the upper and the lower, we now understand why we need to put a spacer. We could relieve in different ways. Putting a spacer and then removing it before impression does this relief. Or we can fabricate a tray that has no spacer in it, but in the areas we need relief, just before adding the handle in the areas we need relief, we put in holes. under impression, the impression material can escape from these holes and the pressure beneath will be reduced. While on the slope area where no holes are present, the impression material is compressed between the tray and the tissue, and we will have a tissue compressive status. So tissue static here, tissue compressive here. From the upper, we place the holes in the following areas. Once more on the areas we need to relieve, which are in front of the tuberosities, over the crest of the ridge, over the incisor papilla, the Runge area, and the mid-palatine suture area, just before placing the handle. Once we place the handle, we will have the following situation with holes inside, and impression material is free to escape from these relief areas. So we have talked about the quality of the mucosa and the soft tissue beneath the denture. We said that beneath dentures we have multiple quality of soft tissue and bone beneath them. So if we look at this area, this will have thin mucosa and sharp bone, so we should relieve it. This area has thick mucosa but very irregular, and they are oblique in orientation, so we also need to relieve them. Under the incisor papilla we have a bundle of blood vessels and nerves that can be compressed, so this is an area of relief. The crest of the ridge, if well formed, still has under it cancellous bone that is highly resorbable, so the crest of the ridge is an area of relief. If the crest is also sharp, we add to that it would have a sharp bony projection. But those are for what we call knife edge ridge, and these are more common in the lower. We'll look at them in a moment. Also, if we have undercuts, areas of undercuts are usually covered by thin mucosa that is easily traumatized. Although the bone is beneath them is good, but the thin mucosa is very vulnerable, so it can be traumatized under pressure of the denture. So these areas should be relieved. While the rest in white of the basal seat area, the rest in white are what we call primary support structures. The tuberosities are secondary supports, especially if it's fibrous and firmly attached. This firmly attached tissue, this bulbous tuberosity, could provide good support, but it's called secondary support areas. So we understand that now, for a denture to be successful, we should compress the tissue beneath it and make these areas in orange all relieved, even under the pressure. So this is what we call selective impression technique. In the lower, if we revise them, cancellous bone beneath this good attached mucosa, so the bone beneath is of poor quality on the crest of the lower ridge. And sometimes, because of the pattern of resorption, we might have what we call knife edge ridge. It has been resolved from the buccal and lingual a lot, but we still have a knife edge. The quality of the bone here is sharp, so this mucosa could be crushed between the hard denture and the bone beneath. And we have openings of foramen. These are the openings of one here and one here for the mental foramen. So also with a lot of resorption, this foramen might even be on the crest of the ridge, and this is an area of relief. Other than that, the slopes from the inside, from the outside, from the buccal shelf area, it's called the primary support area. From the slopes on the lingual, these are all areas of support. In many cases, the places where we usually face the undercuts are around the lingual pouch from the lingual distal area. Sometimes we have undercuts. If we have the issue of undercuts and bulbous exostosis before this undercut, it will be covered by thin mucosa and we should relieve them. So these are the areas of relief and supporting the upper and the lower. Now, for us to make the tray not press too much on the tissue while taking the impression, and this is called selective pressure technique, we can do more than one procedure. We can either select the areas where we pressurize and the areas that we want the impression to be static by placing the wax beneath the tray. So if I make a tray material, hard tray material over this wax, in the areas where we have wax, the tray will not come in close contact with tissue. And once I want to begin my impression, I remove the wax, and the impression material here will have a lot sufficient space. While in the areas of support, the support areas, the impression material will be closely and firmly pressed by the tray and the soft tissue, so these are compressed. While the areas where the wax was, it will be mucostatic, not mucocompressive. Another method is to make a tray without any spacer, but these are supposed to be trays, they're going to be completed as trays, but just to show you that in the areas where we want to relieve, we can place holes in the tray itself, the solid material. So even if a tray comes from the lab to you with no perforations and no spacers, you can add in the drilling of the holes by using there. And then, while we're taking the impression material will be squeezed out of these pores or these holes, and this will reduce the pressure on these areas. While in the areas where no perforations are there, the impression material is squeezed between the hard tray material and the soft tissue. So this also provides tissue compressive properties in areas, and while in the same impression we're doing some tissue static impression for the areas where we have holes. But if we have the case of full wax relief or no wax spacer relief with no holes, what will happen is either all of the impression material will be compressed against the soft tissue, and we will have problems later with the compression of the soft tissue in areas, hazardous areas like the nerves, for example. They will have pain in the patient, or we will have resorption of the bone in the crystal bridge, or we might have trauma to the mucosa, thin mucosa around undercuts and maybe bulbous bone or neck ridge. So pressurizing all areas equally could, on the long term or on the short term, harm the patient. But in the cases where we take an impression with a full relief, we will have that the denture, while functioning, will be put on the tissue while in resting position. So, all of the areas covered in wax, once we take out the wax and begin the impression procedure, these areas will all be taken as static. Nothing is compressed or recorded in a compressed status. Once we place the denture and fabricate the denture over resting tissue, the denture as a solid material and under occlusal function will not stay solid, and it will not stay in place. It will not stay in its place while in function. It will be going in and out by the compressibility of the tissue. This extra compressibility or the denture will sink in more into the tissue and once more exert pressure on areas that we should have been relieving. So also the denture could also go through the sulci and go in here and cause trauma to the patient later on. So taking a case where no relief is present or full relief is present are both on the long term hazardous to the patient and might cause harm. So for our purpose we choose to do partial relief. For your lab work, you will be doing the upper partial relief wax, and then we'll place the tray material over it. And for the lower, you're going to do the perforated way of relief, for you to have main experience in both methods of relief. So for the upper, we're going to do partial relief, and for the lower, we're going to do whole relief against the tissue that we need to be static. Just a final point about the borders of trays. We are going to use this special tray to do accurate and precise impressions of tissue that aid in the retention of the denture. And these are the sulci and the borders of the denture area. And as well, we will be recording the full anatomical surface, which we call basal seat area, which is the area that is opposite to the denture. So, to make this in an accurate way and in a precise way, we do it in two steps, where we add to the borders what we call green stick material, and after we have finalized all of the border molding, which we'll be talking about next video, and we remove the wax, we're going to take an impression using Greek oxide gel. So to perfect border molding, which is adding green stick to these borders, we need to make sure that we have space for the border molding material. How do we create space? By making our tray short from the sulcus. The tray is not in the full depth of the sulcus. The tray is short from the sulcus by around 2 to 3 millimeters. This allows a space for the green stick to be placed inside the mouth later on. So, the outline of the tray will be away from the sulcus. So, the border all around will be short from the sulcus by 2 millimeters. We also need to make sure that the handle can accommodate the lip without distortion. If my handle is going to the outside, what will happen is that it will interfere with the lip of the patient. So we need to make sure also that the handle is clear from the lip by making the first part of it vertical, and then we rotate to the outside just to make enough as a grip while holding the and taking the impression. So if the lip of the inside the patient's mouth and the lip is here, you can notice that the lip will be resting without any distortion or movement. So I can hold my tray, insert it, take it in and out without distorting the lip. So this will aid in an accurate impression as well. So to begin for our first step, we need to outline the basal seat area, which is the area that can come in contact with the denture. We begin by holding a pen. We need to know where is the depth of the sulcus. So we hold the pen vertically and we let it run in the sulcus all around the cast. Okay. We will find that on the areas of freni, the pen will go in up and down. And this is the sulcus morphology around the frenal attachments. We also go inside the hamular notches. From the hamular notch to the hamular notch, for tray purposes, we make it straight. And then we will change it later on. But as the tray should be extending from hamular notch to hamular notch to record this area, which we will be using for pulse down later on. We will be talking about that later. So from hamular notch to hamular notch in a straight manner, vertically in the sulci, up and down on the freni area, and going to the labial frenum. This is what we call the full sulcus depth. This will not be the outline of our tray. The outline of the tray is far away from this, by 2 millimeters. So when I'm going to draw the outline for my tray, I should draw the same line, the same morphology of the line, but 2 millimeters away from the depth of the sulcus. That's why we drew the first line, to make sure that we're drawing 2 millimeters to 3 away from the sulcus. And once more we follow the same morphology, so on the freni area we have to make these notches. We follow on the labial area. We follow to the labial frenum. And once more allow clearance for the labial frenum. And to the other side with the same features. Freni notches opposite to the freni in the tissue. I go behind until I reach the forehead. For the posterior area, these two lines meet. We're going to make the tray on the same line it draws posteriorly. So these two lines meet in the hamular notch area. So the tray should extend into the notch. It doesn't end on the tuberosity, it's inside the notch, the hamular notch. So this is our outline of the tray. The third step is we draw the outline of the spacer. And here we're following the partial spacer shape. So we're going to draw the line over. We're going to add the lines over the areas that we should be relieving. So mid-palatine suture, just revising them. The rugae area, the crest of the ridge, up to the tuberosity. We exclude the tuberosity. The crest crest of the ridge, so it's over and away from the tray border. So the crest of the ridge, the incisive area, the rookie area are included inside these lines. We go all the way to the other side, exclude the tuberosity, and this is our relief area. Now the areas in white between the border of the wax and the border of the tray are all primary support areas. So these are all primary support areas where the impression will be in a mucocompressed status. Okay? Except for the tuberosities called the secondary support area. So these tuberosities are also in close contact with the tray material. We're not going to do anything on them, but I'm coloring them in yellow just to differentiate them from primary support areas. So whatever in white is primary support area, secondary support area, primary support areas on the slopes of the ridges. This is for the lower. For the lower, we are going to follow the perforation method. So for the perforation method, we are going to repeat the sulcus, drawing of the sulcus. So once more, we put our line, our pen vertically, or pencil if you colored pencil in your case. So just let it run through the deepest areas of the cast. In the posterior area, we should cover in the tray, inside the tray, the whole of the retromolar pad. In the impression we include it all together. All of the retromolar pad is in there. But in the denture, not all of the retromolar pad is included in the denture piece. But for the impression purpose, we need to record the whole retromolar pad because we want then to select the areas we need to include inside the denture. So the impression is a bit longer and more distant than the denture borders in the posterior areas. So this is the outline of the sulcus. This is not the outline of the tray. The tray should be 2 millimeters short and away from the tissue. But once we reach the posterior edge, as we said, the two lines meet. So posteriorly, the two lines meet. Now I'm going to draw on the lingual. Line. Or the lower tray. We will make it a full coverage tray with no spacer. But then, once we have our material ready, we are going to place holes in the areas where we need to have relief. So the holes in the tray will be over the canine eminence, over the crest of the ridge anteriorly, the canine eminence on the other side, the crest of the ridge, excluding the retromolar pad. The retromolar pad should be compressed indenture impressions. So we can apply these holes in the tray once it's there. To maintain that the stopper area is not reduced while taking impressions of the wax relief, we place what we call stoppers. These are openings from which the acrylic will come in and touch the tissue inside the patient's mouth, so the impression is not squeezed more than required into the patient's mouth. So in the wax, we're going to place stoppers. 2 in the posterior area and 2 in the canine area. So these are stoppers. So, now you're ready for the step where you're going to draw the outlines and then consult with your supervisors and helping staff with the outlines that they are sufficient for the purpose. You have 10 minutes to make the partial relief wax. We're going to use a wax that has a known thickness. Base plate wax comes in boxes, and it's usually thin coated. This wax has a uniform thickness of 1.3 to 1.5 millimeters. So we're going to use this as our spacer. We're going to do one for the upper, so we're going to cut enough material for the upper. And we need to adapt this to the cast. Like this, it's a bit firm and solid. We need to make it soft enough to adapt it to the areas we have drawn. So we're going to use our flame. This is where we ask you please to put on the flames on your benches carefully and make sure that all fire safety regulations that have been given to you in the lab are followed. We heat the piece of base plate wax until it is soft enough that it doesn't hold its weight. You can see that it's going and flowing, and I'm also heating it from multiple sides. This is called tempering, which is slowly heating the material. I don't allow the surface to drip, so the wax on the surface is not dripping. It becomes a bit light in color and pinky. So we go in and out, in and out. Going in on the temperature heats the surface. When we go out, we allow sufficient time for the heat to diffuse to the inside. Wax is not a good thermal conductor material, so we need time for the heat to diffuse from the surface to the inside. So we heat it gradually, this is called tempering, using dry flame. And once it's soft enough, we just put it on the cast and begin adapting it. We usually adapt from the middle first. Adaptation doesn't mean pressing, it's simply just shaping. So I don't press firmly on the wax, because if I press more, this wax will become thinned out, and I lose the space that I need. So the adaptation means only shaping the wax into the shape of the cast. So it's now fully adapted to the cast without any extra pressure. The even thickness of the wax is maintained all around. And now, because I have drawn on the cast using a dark marker, I could see through it. Now I can use my lacquer cutter and begin cutting off the wax in the areas that I am intending to leave exposed for the tray to come in and touch the areas of the wax I've maintained. So, follow the outline that I have drawn, exclude the tuberosity areas, go around the sulcus, just including the around the crescent bridge, and away from the sulcus. I am excluding the sulcus. And following the morphology of the material itself and the borders. So wherever I feel I might have a notch in the outline of my wax. I go in till the end, stop at the tuberosity area, and I'm going to remove the rest. Separate the rest. You notice that the wax is still warm, so after I remove the excess, I could still adapt the material even better to the borders that I have used. A bit short from the border area, just a bit short. Then I'm opening the boxes. and one in the canine area. So, the tray material, as it's touching the support areas, it will touch just over here to maintain the space. If these stoppers are not there, the tray might tilt while taking the impression and we lose the space we have formulated or made in this cast. So tray material will stop here, maintaining the space. And this is the partial relief for the upper. Now you are asked to do the wax adaptation for the partial relief of the upper face. Now we're going to do the step where we're going to construct a tray over this space. For trees, we need them to be hard and rigid. So we use a material that is easily shaped, and once it's set it becomes hard, and the suitable material is acrylic. Acrylic can come in light cure or in cold cure method, powder and liquid mixture. For students' purposes, we use the light cure because it has an advantage that it's playable for a long time. You can work, you can modify, you can add and remove while still having time. And once you have finalized your shape, you can light cure it to become solid. So has more working time. Light cure material comes in a light-proof box, and this is also sealed with sheets, multiple sheets, and then we have the material covered up in multiple sheets to protect it. So this is called light cure material. We'll make sure the box is sealed, and the sheet we get comes in a shape that is corresponding with the shapes of most casts. So it has this out form where anterior, posterior edges are there. It also has uniform thickness. So although it's like a dough, it has a uniform thickness throughout. So when we are going to do our steps, we are concentrating that you, once more, adapt but not press or thin the material. So we're going to adapt the material with our fingers from the palette first, then over the crest of the ridge, we're simply removing any voids or any air trapped inside, and then we run from the crest downwards. To adapt inside sulci, we could need the back of a vacuum carver or the back of a wax knife to press the material inside the sulcus and against the tissue in this area. If it becomes difficult, we could follow the following, where we simply just remove the axis of the material from the outside of the round area, from the outside of the cast. I have adapted it as much as possible. The material is going over the sulcus. This is the exposed sulcus I have adapted it to. But over the land area, I just remove the excess. So fully adapted as much as possible, and then remove the excess. And this excess comes a bit longer, so we can fold it into the sulcus once more. So adapt as much as possible, and then over the land area, just remove the excess. And then, by the back of the instrument, or even the back of a pencil if we have, we can adapt this material from the outside to the inside of the sulcus and then smooth it. Okay? We make sure it's fully adapted, not pressing it, not thinning it. We're just doing the adaptation step. So we keep the thickness of the material uniform. Once we have all of the material in location, we can now, the material is adapted, and now we can cut to the line that we have drawn, which is 1 to 2 millimeters away from the sulcus. We're following the line. It drove 1 to 2 millimeters away from the surface. And we're removing the excess. Once more. We have the material inside the haminar notch, straight to the other haminar notch area. So it's included in the borders of the tray. You can see that we're taking our time because the material will stay soft and could be adapted all throughout the time until we light cure it. But that doesn't mean that you work with it for a long time, because the light from the room itself might initiate some reaction. So it's better to finish it off as soon as possible. So this is our tray material added. Light cured acrylic, once I put it inside the light, it will initiate a polymerization reaction, and this polymerization reaction might cause that it shrinks a bit. And this shrinkage or polymerization of the material might take the tray away from the tissue. So there are methods where we cure part of the material first, and we light seal this surface, and then cure the surface alone. So before light curing, we can add any material that is opaque and cut it into this shape and just add it into the palatal area. This will reduce the shrinkage while we are doing the light curing of the material. For the handle, we can take the excess that we had and mold it into the form of a roll. Okay. We press the excess from one side, so we roll it, and it will have this shape. We make the base a bit wider than the upper part. This will allow us to adapt the tray handle to the tray body well. So, first of all, we made it wider from the base than the tip of it, and we press it like this, so we could adapt this easily to the tray from beneath. Once we have adapted it like this, we keep pressing on the sides until the junction between the handle and the tray becomes smooth. You could not see, you don't see any lines between the two materials. So, this is the first issue. So we make sure that from all sides that it's fused, the parts are fused together. Now, for this part, we then elongate it, and we can put our finger to make or mimic the lip. So this is our finger, it mimics the lip. We need to make sure that the body of the handle, this part of the handle, doesn't interfere. Because if it was like this, the lip will be pressed away from its location, and thus the seconds will not be recorded correctly. So we need to put our finger in the first 2/3 of this to make sure that the lip is not interfered with in the handle. And whatever is remaining, we just flip it to the side and flatten it to form the grip from which the dentist will be holding while we cure the material. So we have the body fused to the tray, the body of the handle, this part is fused to to the tray all around. There are no, we should not see any lines in between. The body goes up vertically, or a bit labially, it's okay, but vertically is more safe. And then, on the last bit of it, it bends to the outside and it becomes flat. This provides a grip for the dentist when he's holding the tray in and out of the patient's mouth. So if this is the patient's mouth in the upper, the dentist has a grip to hold the tray and put it there. And now this is ready to be light cured inside the light cure. But take in mind that sometimes the material, the light cure material you're using might flow back in down. So we might need some support here to be placed inside the light cure. So now we're ready for the light cure. Once we place it in the light cure, or wait for it to be placed in the light cure, this is what we said about the handle. Sometimes it slumps down. So we need to put it back, and when we put it in the light cure, we're going to support it by using that. Another issue is that the light cure acrylic material has what we call an air-inhibited layer. This layer does not fully sit on the surface because it's contact with oxygen. So we could add Vaseline to the surface. We could add Vaseline to the surface. This will reduce the air-inhibited layer. And also Vaseline will aid in the fusion of the handle to the body of the tray. The body of the handle to the tray material. So using Vaseline, it will smoothen the surface. It will aid in the adaptation of the handle to the body of the tray. And it will reduce or prevent the air-inhibited layer. So the material once sits, we will not have the tacky part on the surface. And we have here the opaque layer. This will reduce the shrinkage in the palatal area. And fully adapted from all sides. We also make sure that there are no projections inside the surface outline, because it's better or easier to remove it when soft acrylic than in finer material. We place it inside the light cure. We might get another cast, tool, or a cup, or any other object, hard object, that could support the handle while light curing the first light cure. Okay. Stabilize it, make sure it's stable, and then we begin our light cure. The time is set for 3 minutes, and we will begin the light cure process. The light cure machine rotates while it's light curing. This will expose more parts of the tray to the light all around. But even with this rotation, sometimes parts of the tray do not become solid, meaning after the first light curing cycle to take out the tray from the cast, take out the cast, and expose the fitting surface of the tray to the light as well. At the middle of the cycle, I could open this and remove this part I was placing, because the support will be preventing the light from reaching to some parts of the cast. As well, I'm removing the opaque layer that I placed on the palatal side to expose those areas now, and it could continue its cycle. We're going to wait for 3 minutes to finish, then we are going to open it, take out the tray and the cast, separate them, and put the tray alone for the fitting surface. Now that the first cure has finished, we're going to remove the tray, separate it from the cast. If it's firmly attached, we can utilize our active carpentry. This is why sometimes with cases where we have undercuts, we should relieve them with wax before making the tray, because the tray is solid. So if we have undercuts and the tray material goes in the undercut, it's difficult for us to remove. But in this case, we don't have undercuts in this case. So we are inverting it from the other side, and we're doing a second cycle of curing. Once removed from the light cure, we find that wax is embedded inside our tray. The tray material covers all of the borders, so no wax is exposed to the borders. The borders are fully cured, the handle is fully cured, and these borders follow the border shape we had in the beginning. And notice that the adaptation of the tray in this case is fully adapted. Not a lot of shrinkage happened because we covered the filleted area and reduced the shrinkage during the setting. Once we remove this, this is ready to be trimmed, smoothened, and then polished all together. So this is for the upper. We're going now to do the trimming step. For the lower, you have drawn the outline, and then the outline of the tray. Then we're going to adapt the tray light cure material over the tray immediately and light cure it. And we're going to place the holes in the light cure material or acrylic base material before curing it. It becomes easier. So if you had cured it and it becomes solid and you want to place perforations, you simply come in with the bare and trim them. But it's easier for you to make these holes in the light cured material while it's soft and then cure it. And this leaves us with the tray body ready, and then we add in the handle with some excess of light cured material. So we formulate the handle. Once more, we form it in a roll shape first. Then we press our thumb and begin rotating it against our thumb. This will widen at the base area and thin the outer area. In the base we place a groove, and this groove can adapt to the cast. In the case of the lower, the tray itself is thin in the interior margin area. So we need to make sure that the handle is not bulky over this area. Once more, we adapt it well to the tray. And to make sure that it's adapted well, when we have done the first layer, we don't place Vaseline in this area to make sure that the handle adapts to it. And wherever a hole is covered, we re-expose it to make sure it's still present in the handle as well, with the presence of the handle. So, the handle is in. We thinned it. We have removed the bulk from here. We have removed the bulk from here. We're placing our finger to mimic the lip, and then we go over that distance. So we have preserved the lip length, and over that distance we have bent the handle, and then we flatten it into this shape, so that the dentist will have a good grip over this area. So once more, if I leave it, it will slump down. I don't want to cure it while it's still up, so once more, I begin my curing with a material with supports. I could place an old cast to do this purpose. I support my material so it doesn't slump in a manner that we don't want. We do an initial cure. We can wait for 20 seconds or more, and then once open, interrupt the cycle, and then remove the support. It's still soft, so I'm not going to remove the support. The idea we need to remove the support while it's curing, because the support material will be preventing the light from entering into that area where it's touching. So we need it solid enough, the handle solid enough to take the support away and complete the curing cycle. Once more. Now it's hard enough. I could remove my support material and then cure it fully till it's finished. Now we're going to trim the borders. Although we have cut the borders to the line we have drawn, the cut itself is sometimes rough and it produces sharp edges. These sharp edges will traumatize the patient while we're working. So we need to round them out. Not reducing the length, just rounding them out. So we're going to use your handpiece that you have. To take in the burr end out, you need to rotate the handpiece, put your acrylic burr in, and then secure it. You need to make sure that burrs are secured before working, because if they are not secured, they might come out and traumatize you. We're going to use the handpiece control unit that you have on your chair. So you can see here that this is the on and off button, and this is to control the speed. So if I press to operate this, it will not work because it's on 0 speed. If I raise the speed, okay, the handpiece will be working faster. You can notice that from the sound of it. So we could put it to the maximum speed, and we're going to use what we call knee control. So my knee, I press it against this large button, and it will operate the material, the handpiece automatically. So I also would like to notice that I'm holding with what's called with safety grip. So I hold the handpiece with 4 fingers, and I leave my thumb out to press on this material that I'm trimming. If I don't have this hand rest, I'm working like this, it might slip away and traumatize me. And in any way, because it's not safe. Sometimes you're pressing so much and it simply slips away. So we need to make sure this slippage, if it occurs, it is controlled. So we put a finger rest here and we work. So even if this slips away, my finger is preventing further movement. So we need to work with the cat. If I'm doing a border, we don't point with the burr onto the surface. We put the full length of the burr on the surface. So this is the full length of the burr, and I'm simply running over the border just to remove sharp areas. In the areas where we have the free line, I open the options. These are the areas where we have the free line on the cast. So if I place it now, you can see that for each frenum I should have a notch in the tree. So this is the frenum area, and this is the frenum area, so make sure that notches are clear in them. Further smoothing the surface, going around the borders on the upper side, going into this notch and smoothing this, and making sure that all of the edges are not sharp. You can see my finger at all times. I'm holding the tree firmly. I'm just running over the border to remove sharp areas, and you can notice from the light gathered produced that these are now smooth. So it becomes an area rather than a sharp edge. In our case, if we place Vaseline on the surface, we don't need a lot of trimming on the surface, or any trimming. On the borders, if they are rough and kept rough, not sharp, but a bit rough, this would aid in the retention of the green stick later on. So I will leave these rough borders present, but they are not sharp. They don't injure the patient. They're only just rough enough to hold the green stick into place.
hand over the final border.
Once I'm finished, if I run all around, I should have no sharp edges. There's a sharp edge here that I lifted by my fingers. So I should have no sharp edges. There's a raised bit here. A bit rough, but not sharp. This is where you need your old toothbrush where you can brush away the particles. And then I adapt it back to my cast and make sure that all of the borders are following the orange line here. For this purpose of training, I have just exposed a bit more for you to see the lines. The tray is shorter than the sulcus line in this case. The handle is vertical in its first 2/3 of it. Then it goes to the side where I can get a grip. The surface is all smooth all around. The thickness of the lattice material is uniform all around. I have not overpressed it in any way. And this tray is ready for step number 2. And it contains the partial relief inside, embedded inside this tray. So this tray is ready. You're going to finish the upper tray only. And for the lower tray, it's just for you to put in the holes before you cure, and you're going to train on that. But the submission will be on the upper tray. So you're free now to go in and begin working with your tray.